if two events are independent or dependent. So let's talk about the English definition. So if you're independent, that means you can do stuff kind of on your own. You're by yourself. So as far as tax law is concerned, probably nobody in here is independent because you're all living under somebody else's house and eating their food and they're buying you clothes. Okay, so you are dependent upon them for stuff. When it comes to probability, our definition is right here. Okay. Things are dependent if one event depends on the outcome of another, and really we should say prior event. So this will make a little more sense in a minute. Okay, independent would be things like flipping a coin. Every time I flip a coin, it's still a half chance. But I got it 10 times in a row. Is the next one going to be a heads again? No, it's still a half chance of getting heads. So it's completely independent every time. All right, let's take this, slow this down a little bit. Take a look at this. Read the situation, and then let's determine if this is first dependent or independent, and then we will calculate the probability. So if we focus in on our sample space, we're only looking at pairs. All right, so they took a pair. Did they put it back or they keep it out? Okay, so where does it say that? Okay, so with replacement indicates that these are independent. So it's like you never took that one out in the first place. So each time we pull out is independent of the prior one. Independent. Okay, so we have 5 sets of socks. Do we have repeats of any of them? Nope. So they're 5 different colors. So the first time I pull them out, that is 1/5. I put them back in. So what's the chance of me pulling a red sock again? 1/5. And then I multiply them together. Okay. So the chances I pull out a pair of red socks 2 times in a row is 1/25. And that's all there is to it. Okay. Not too complicated. Will it get more complicated? Yeah, not a whole lot more. And it's very logical. And then, like I said, the arithmetic, when you set these up, is going to be easy. So you can see when you multiply them, it's going to get a little bit more complicated. But that's okay. We have Desmos. All right. So this one's a little bit different. Okay. Take a look at these two. Well, let's just take a look at the first one. Okay. So you randomly pick a card from a standard deck of 52 cards without putting it back this time. So let's talk about that. So I don't have 52 anymore. So that means my new probability depends on what I just did. So that is dependent probability. So take that into account. And let's see if you can calculate the probability of first pulling a card is a heart, and the second one is any black card. Write it in simplified fraction. Write it as a simplified fraction. So do number 1. So there are 2 ways to look at this. Okay. First way is the way most of you kind of look at it is like, well, I got 52 cards in the deck. Okay. So make my fraction denominator 52. So then I have to count. Well, I have ace through 10. That's 10. And I got jack, queen, king. That's 13. Oopsies. So that's one way. Or you can say, how many suits are in the deck? 4. I got clubs, diamonds, spades, and hearts. And one of those 4 is a heart. Hey, which is the same as 13/52. Okay, so 1/4. I have a card in my hand. Am I putting it back? So my new fraction, I have a new denominator, don't I? I don't have 52 anymore. I got 51. How many cards are black? 26. Is a heart black? No. So I don't have to worry about that. But if I said a heart and any red card left, do we have 26? We're going to have 25. You see how this can get a little complicated? Okay. Does 4 go into 26? No. But 2 does. I mean, you can use Desmos if you want, but 2, 13, so 13 100 Sounds weird, I know. 13 100 seconds. Okay, the second one's a little bit more complicated. So I want you to discuss why this is more complicated, and I'll give you a hint why it's more complicated. They're actually 2 different answers. Okay? So look at the second one, discuss it with the people near you, and figure out why there are two different answers, and then find both answers. Okay, so let's assume our first card is not the two of diamonds. So how many twos are there? How many twos are there? 4. So at the beginning, I'm going to use my equation editor. I have 4 twos out of a total of 52. Is that the same as 1/13? Okay. How many cards do I got left? I have 1 card in my hand. 51. And if the first one's not the two of diamonds, how many diamonds are left? So I either have a 2 of clubs, 2 of spades, or 2 of hearts. How many diamonds are left? I have all 13. Okay. Hey, look what happens to 13s. They divide out, and it's 151st. Okay. But if my first card is a 2 of diamonds, now it's a little different. Okay. So the first part's the same. It's still 1 out of 13 because there are only 4 twos. Remember, everything's back in the deck. But now, how many diamonds do I got left?
12.
I only got 12. Okay. So this one, guess what? 12 doesn't go to 51. Well, is parts of 12 going to 51? Remember, Julie, divisibility rule for 3?
Oh, yeah.
Can you read it to me, please? What's 1 plus 2? 3. Is 3 divided by 3? What's 5 plus 1? 6. That's divisible by 3. So I can simplify this. 12/51st. That's for, how many times is 3 going to 51? 17. Okay. And then, you can either do that in your head or just dump it in decimals. I don't care. Okay. 4 over 221. So let's just take a look how different that is. So I got 151st. It's 0.0196 and 4 221st. It's not that different. It's only off by 1,000. So even though I pull that 2 of diamonds, okay, it's not going to change the problem that much, but it is different. Questions? See how it can get complicated kind of quickly?
I don't like that.
What's that?
How was that one 12?
Because I have a 2 of diamonds in my hand. How many diamonds are left? I took 1 away from 13. I only got 12 left. Okay. All right. Yes, sir.
Why is the denominator still 51?
Because I still only took 1 card out. This is 2 different. It's a scenario, which means if it was. So I don't. It's not like I have 2 cards.
No, but aren't you supposed to multiply 13 by 51?
Well, I could multiply 13 times 51. Okay, these are 2 separate scenarios. So I'm going back to putting all the cards back in the deck. But this one, if the first card that I pulled was the 2 of diamonds, I still only have 51 cards left. And of those 51, I have 1 less diamond. I have 12 diamonds left. Okay. So when I have 2 different scenarios, it's like a do-over. I'm going back to pulling my first card. Think about it a little bit. I'm sorry.
Why is it 1 out of 13?
Because there's 4 twos in the entire deck, right?
Yeah.
And 4 52nds simplifies to 130.
Oh.
Okay. So that's going to be true for any number, or Jack, Queen, King. So if I'm trying to figure out what's the probability of pulling any Jack, any Queen, any King, any card at all, it's going to be 1/13. So it's not a good bet to have hey, I bet I can pull a Jack. Yeah, that's 1 out of 13 chance.
It's fine. You do it.
So I'll talk about this a little bit later. But what is a good bet? Okay. And this is all about probability, and I'll show it to you probably next week. Someone remind me. It's called the birthday problem.
Oh, yeah.
Okay? So the birthday problem is this. Now listen carefully, because it's not specific date. So it's not like you can pick a day of the year. But if you have a room about this size of about 25 to 30 people, if you have 30 people, the chance of 2 people having the same birthday, I think we did this already.
Yeah.
Okay? It's 72%. Okay? It's, and I'll explain the probability part next week. So it's Santiago and Caleb, right? Okay. So it's not like the same birth date, like
Same
born
month.
on the same day. Okay, same date. So different years. Okay. All right. All right. Coin is tossed. 6-sided die. Independent or dependent? These are independent. They're two separate things. So let's write that down first. Independent. One does not depend on the other. Or I dependent, yes.
Yes, I dependent.
Okay, find out your probabilities for 1 and 2. 1 out of 6. So half times the 6th is 1/12. Okay. So 1/2 for the coin, 1/6 for the die is 1/12. Okay, probability of rolling an even number. How many evens are there? 3 out of 6 or a half, because we only have evens and odds on a die. There's no like numbers with fractions and stuff. So half for the die, and tails also a half, so
1/4.
1/4.
Would
Okay.
0 be
Good
an
probability.
even or an odd?
So 0 would be an even number if it's on a die. Okay, it depends on the type of die, but a standard die, it's just the dots 1 through 6. Okay, but if you play some different games, and I've had some games where the 0 has been on the die.
Right. 0 to 5.
Is 0 on the? All right, 10 marbles, 5 red, 3 black, 2 white. Pick a marble, observe it, then pick another one without replacing. Therefore, dependent. Okay, so go ahead and answer both of those ones. Out of 10, right?
Yeah.
So we set this up 5/10. Or 1/2, because half of them are red. I now have a marble in my hand. How many marbles are left?
9.
9. So new fraction, denominator 9. How many red marbles are left?
4.
4. Okay. So it's really half of 4 9s, which is 2 9s. Okay. The next one, same start. I still have, so put
Shut up. But
half.
You're
I have 9,
yeah, shut up.
but this time I'm looking for a white. How many whites are there? Half of 2 is. Okay. So even though I'm picking 2 different colors, it's still half the probability because I got so many reds. That's why. Okay. Questions? So half of 4 9s, and then really half of 2 9s. Okay. All right. Work that one out. The right one, a lot of people have issues with. Okay. Left one's not so hard. Right one, for some reason, people had issues with. It's actually 2 different things. They're basically asking the same thing. Are my probabilities dependent or independent? It's independent. Okay. So I got 1/4 times 1/4. Because not like I took a color away, right? So they'd be dependent if I took a color away. Remember, this is 2 rounds in a row. So we're not playing Twister where the person has the hand on there already, and then the next person only has 3 colors left, or, okay. Well, it depends on what you're spinning and that kind of stuff. So 1/4, can we write that as 1/4 squared?
Yeah.
Which is 1/16?
Yep.
You guys didn't have any issues with that one, but then here you're like, ah! Almost everybody put the 9/10 down, and then you did things like, let's multiply it by 3. Your probability can't be bigger than 1, so you can't multiply it by 3, but you had the right idea. Your instincts are correct. Where's the 3 go? Exponent. Okay? So if I do that, 729 over 1,000. So if I asked 1,000 students at this school, 729 of them say they like pizza. Okay? So you're the one who's not. Okay, so
Well, it's just some. It depends what kind of pizza.
of course,
I only like one place.
Domino's. That's the only right answer.
Domino's
Well,
is
there's
trash.
there's two.
Domino's is good.
Literally, the Ninja Turtles like Domino's.
Wait.
And I know that. And I know